Alright, so we are going to be graphing different lines and tables today. Well, graphing tables today. And we're also going to be making equations today. So you remember last chapter we skipped the equation part? This time we're going to make the equation. But it's not going to be super tough because you know how we did the words? The words is going to be really similar to our equation. So we're looking at linear functions, just a quick review. Y changes by the same amount each time x changes by 1, right? So that is actually going to be part of our this part right here is going to be pretty important when we make our equation. And the equation we are going to use today is y equals m times x plus b, or y equals mx plus b. Any of you guys remember using this before?
Last year.
mx plus b?
Yeah.
Yeah, that's a pretty popular one. So you guys probably done it before, which is good. We'll make this easy. So, in this equation, really, we only care about two things. I really only care about the m and the b. The y and the x are going to stay y and x for the most part. They're not really going to change. So, in this, m is how much your y changes by each time. So you remember how we had our table here, and then we said, oh, this was like a +2, and this was like a +2, and this was a +2? We'll do this again. I just kind of want to give you a reminder. Remember how we did this, and we said, oh, they're all +2, so it's linear? That +2 is your m, which we'll see in a second. And then you remember how when we did our words, we had to say where it started, and then how much it changes by? The where it started is b. B, it's where your graph crosses the y-axis, or another way to say it is just where it starts. Write the word where. So it's a little bit backwards from how we said it before, but it's still the same thing. We're still going to look at where it starts, and then we're going to look at how much it changes by. So we're going to go through, we're going to make some equations, and we're also going to graph these equations. Give people a second, finish off the notes. No, it's just +2. Yeah, don't worry about this part right here. We'll look at this more in a second. Yeah, we'll get that more in a second. All right. We are going to look at this table here. We are going to determine if it's linear. If it is, we're going to make an equation, and we're going to graph it. So, on this, remember when we talked about if something was linear, we needed two things. I needed to make sure x changes by 1 each time, which that works. X changes by 1, which is good. And then I need to see how much y is changing by. And I need to make sure it changes by the same amount. So if I'm going from 1 to 2, how much am I changing by? So I'm going to go up. It's up 1, right? So I'm going to go +1, so I'm changing by +1. 2 to 3, +1. 3 to 4, +1. All right. What I'm going to do is I'm actually going to make my equation now. Last time we did words, this time we're making the equation. So we're doing y equals mx plus b. I need to figure out what m is, and I need to figure out what b is. M is how much I change by each time. What am I changing by each time? What are my y's changing by each time? They change by 1, right? My m is the number 1. I'm going to put 1 in for my m in my equation in just a second. B is where our graph crosses the y-axis, or the other way to look at it is where it starts. What number does this start at?
1.
It starts at 1. Remember how we talked about words last time? We said start at 1 and then +1. It's kind of the same thing, except this time we're writing it out as an equation mathematically. So I actually have all the information I need to make my equation. What I'm going to do is I'm going to take this 1 for my m, and I'm going to plug it in and actually put the number in. I'm going to take the 1 for my b and actually plug it in and put the number in. So my equation is going to be y equals 1, because m is 1, and then I'm just going to put my x right next to it, and then it's going to be plus, my b happens to be 1 again this time. Usually they are not the same, it just happened to be that this time. So my equation is y equals 1x plus 1. And then our last part, we are going to graph this. So if I'm going to graph this, my x's go 0, 1, 2, 3. That's easy. I can go 0, 1, 2, 3. My y's go 1, 2, 3, 4. Do I need to make my y's go by something other than 1? No, that's really easy. So I'm just going to graph it real quick. So I have 0, 1, my first point. Left and right 0, up 1. And I'm going to put my dot there. And then I'm going to graph the rest of this table. I have 1, 2, let me see, 1, and then 1, 2. And then I have 2, 3, and then I have 3, 4. So I've got this, but I'm missing one thing. What's my last thing I got to do?
Arrow.
What?
Line.
Oh, the line. I heard 0. I was like, what does that even mean? Yeah, we got to make our line and make our arrows. Because we're talking about linear functions, linear means lines, so I need to actually make it a line. All right. So most of this is review from yesterday. We basically did, well, not just yesterday, but the day before. We basically did almost all of this. The only thing that's new is this time we are making our equation instead of using words. So we're going to do just a couple more of these, and that's actually it. Pretty short lesson today. So I'm going to look at this one right here. I am going to graph, say if it's linear, and I'm going to make an equation. So we're going to kind of work backwards. We're going to start with our equation first. So I need to look, are my x's going by 1 each time? Yeah, that's good. And then let's look. On my y's, I'm going from 10 to 7. How much am I changing by? -3 this time. So I'm not just adding 3, I am minusing 3. So I'm going to go -3. And then I'm going to keep going. If I'm going from 7 to 4, how much is that changing by? -3 again. 7 minus 3 is 4. And then if I'm going from 4 to 1, that's another -3. Okay. We have everything we need for our equation. My equation is y equals mx plus b. My m is how much I'm changing by. I am changing by -3. So last time it was a positive, so I just wrote the number. This time, because it's minus, I'm going to keep it as a -3 to let us know we're going down by 3. And then what my b is where I start. Where do I start on this one? 10. We start here at 10. So I'm going to go here to 10, like that. And now I need to actually put this in my equation. So I'm going to put -3 in there for my m, and I'm going to put 10 in here for my b. I'm going to go y equals -3 instead of m, because my m is -3. And then I'm going to put the x right next to it. And then I'm going to go plus b is 10.
Where did you get the
10 is, you remember yesterday and the day before when we did words, we said we start at whatever number and then plus or minus. We start at 10 right here.
So this is kind of like word.
It's basically the words, but we're writing it out in an equation. So if you did the words and you're really good at doing the words, you're good at doing this. You just have to write them in your equation. Because this is the same thing. This says start at 10, change by -3 each time. It's just a mathematical way of doing it. And I'm not really, this is the way you write it. I don't know why we don't put the 10 first and then put the -3x, but I don't know. That's just how it is. And then for the last part, we are going to graph this. So if I'm going, let's look. My x's, I'm going 0, 1, 2, 3. That's easy. I can go by ones. What about if I'm going, what's my biggest number for my y's? 10. So should I change what I make y's go by? No, I can go up 10. That's fine. So I'm going to go up by ones on my y's, and I'm just going to graph it. So I'm going to graph these points here. I have 0, 10, left and right 0, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to put my dot, and I'm just going to keep graphing my dots. I have 1,
7. 1, 2, 3, 4, 5, 6, 7. I have 2, 4. 1, 2, 1, 2, 3, 4. And then I have 3, 1. And we are almost done. We are just missing my line and arrows, which I'm going to make a beautiful line. Oh yeah, look at this. This is crisp.
Nice. Crisp.
Oh yeah. Nice crisp line. You could use that as a ruler. That's how good that is. And that's it. Yeah. Because eventually we're going to take this equation, you're going to take this equation right here, and you're going to graph it without the table. Or you might use your equation to predict something. So we can make an equation represent like a real world thing. Like for example, let's say you have to buy something at the store, you can make an equation and then use that equation. So we can actually use this a lot in different situations, this graph type thing. This especially y equals mx plus b. We're just not learning that yet because we're just learning the equation right now. Eventually we'll talk about how we can use this, but for right now we're just learning the equation. Alright, for your first in-class problem here, what I want you to do is I want you to just make the equation. You don't have to graph it, or yeah, you don't have to graph it, just make the equation. So on your own, on your paper, make your equation. Remember it's y equals mx plus b. You got to find m, and you got to find b. And then fill them in your formula. So make your equation. Don't worry about graphing it. I'll give you a couple minutes, then you guys will help me out a little bit. And then we're going to do like one more, and that'll be it. Like I said, shorter lesson today. Even though it's graphing, I don't think it's too bad. So make your equation. Take a minute or two. Try to get it done.
This one's all.
I think I'm out. You're gonna have to find one. What was that?
Susanna, do you
Just make that equation.
Lead.
It's always, it's not on the one. It's always the very top one. B is.
Don't break it, boy. You can use it.
What else? Some of them. Probably not anymore in the notes, but on the homework.
Oh, bulky, you're in the seat.
There's 2 tape things up there.
Yeah.
Are you done with this, Dylan?
You know.
Better hurry. Actually, I got a pen. I forgot I had a pen. Here you go. I'll give you about 30 more seconds, and then somebody's going to help me out a little bit.
Camera down the board.
Maybe, if I pick you. Or the calculator picks
Never
you.
get picked.
Maybe you'll get lucky this time.
I don't know, it's always Richie that gets picked whenever I want to get picked.
It's Richie.
Really?
Oh my god,
I don't
see,
want
I
to do
told
it.
you.
I don't want to do it.
Oh, no, wait. No, he's the number 10. It's actually Sophia.
Yeah.
Alright. Sophia. Should have changed spots with Zoe. Otherwise it would have been her. Would you write what m equals and what b equals? Then we'll have somebody else make the equation.
Susie,
Well, let's look at it. Alright. On this one, we need m and we need b. M is how much we change by each time on that right side. How much is that changing by each time on the right? Like if I'm going from 4 to 7, how much is that changing by? For m. Yeah, let's do m first. So, on that right side, on where the y's are, I'm going from 4 to 7. How much is that changing by? 3. We're going by plus 3, right?
let's make sure that works for all of them. If I'm going from 7 to 10, is that plus 3? Yeah. 7, 8, 9, 10. How about from 10 to 13? Is that plus 3? Alright. So plus 3 or just 3 is our M. Either one is fine. Take either one. Alright, and then we need our B. So B is where we start. So on this one, where do we start, Sophia? It's by the. It's on the underneath the Y's.
Make it a pencil.
And we start at 4. So B is 4. It's a little high. There you go. So our M is plus 3. Our B is 4. And you know what? I'll have you finish off the equation too. So we're using y equals mx plus b. Your m, you said, was 3. Your b is 4. So rewrite it, but this time put 3 in for your m, put 4 in for your b. So you see how we have that y equals mx plus b up there?
Yeah.
We found the numbers for m and the numbers for b. You just have to put them in now. So let's go y equals. And what number did you say m was? 3. Okay, so put your 3 in. And then right after that, put x, because that's how our equation goes, 3x. And then we're going to have plus, and then what was our b? So put plus 4. There you go. Y equals 3x plus 4. Nice job. All right, we're going to do one more quick one, and then it's not that bad, Richie.
Can we just do it now?
No, one more quick one. Because, just in case you haven't seen this. So, so far, all of our, all the tables we've done so far have been up and down. This table is left and right. When we have up and down tables, remember, it's always x on the left, y on the right. When it's a left and right table like this, x is always the top part, y is always the bottom part. So it's really the same thing, it's just like they took the up and down table and they flipped it left a little bit, or rotated it counterclockwise. X is always either left or on top, which I know it kind of says on here, but I just wanted you to know. So I just want you to keep that in mind. And you know what, we'll skip actually doing the problem because you guys are doing really good.
No, I'm already.
Too late, Allison.
No.
Alright, that's it. So, what I want you to do for your exit ticket, you know what, I'm going to make it a little bit easier. I just want you to find the equation. I just want you to find the equation. Don't worry about graphing it. And then give me a second to turn on Socrative for your exit ticket, and then that'll be it. And I'll put your homework on Google Classroom. So, for your exit ticket, find the equation.